So this is Notes A, page 4. We're going to work at finding the dollar value of a slice of cake to a particular player. So we want to remember that the cake here costs $17. We also want to remember that Bob values chocolate twice as much as vanilla. Okay, we have to remember that. So the question is, what's the dollar value of the chocolate half to Bob? Okay. Well, I'm not sure how to proceed here. So let's do a typical mathematician's trick. The $17 is a weird amount. Let's pretend it was $15. Okay, so if the cake actually cost $15 total, but the chocolate was worth twice as much as the vanilla, how much would the chocolate worth be then? And a lot of you would be thinking, well, maybe it's $10 for the chocolate and $5 for the vanilla. Yeah, that would work, because then 10 is twice as 5, and it adds up to 15. And you'd be right. And my question to you is, how did you get that? How did you come up with that 5 and 10? And hopefully you're thinking, you divided something by 3. Why 3? Well, that's because that's the total sort of parts of value that Bob is cutting this cake into. And so that whole process of how you might have come up with the 10 and 5 breaks down to what I'm about to show you. If you're going to get the value of the halves, and this always has to be done first, it starts with the ratio. And here, if you have trouble with this, communicating to yourself is key. Don't just write down numbers, write down flavors, and let me tell you, I've gotten flavors backwards, so. What's the ratio of the value of chocolate to vanilla? Well, twice as much would be 2 to 1, okay? And if this is sort of not enough information, you can add 2 parts of value to 1 part of value. Now, the key here isn't as much as the 2 to 1, but the key is that Bob sees 3 parts of value. I'm just going to say parts total. The 3 is the key. He's got 2 parts of value here, 1 part of value there, 2 plus 1 is 3. And so we're going to use that 3 to figure out the dollar value of the chocolate half. 2 ways to do this. Once you get that 3 total parts of value, you can proceed in one of 2 ways. You could use your language to help direct you. You realize the chocolate half has, well, it has 2 out of 3, which is 2/3 of, make sure you emphasize, the total value. So does that make sense? He values chocolate twice as much as vanilla, so it has 2 parts out of the 3 of the entire value of the cake. Once you have this statement, you translate it. Has is past tense for equals. The chocolate half equals 2/3 of is multiplication times, well, what's the total value of the cake? $17. And there it is. There's the arithmetic you need to do. 2/3 times 17. And that winds up being 1133. This is money we're talking about, so you need to round to the nearest penny, and I will count off if you don't round to the nearest penny. So there's the chocolate half. That's the dollar value that Bob would put on a chocolate half. He'd be willing to pay $11.33 for that. Here's another way to get that approximately same answer. And for some students, this works a little bit easier. First, find the value of one equal part. Well, the cake is $17. There's the total. There are 3 equal parts. One equal part is $5.67. And then you can use the ratio. The chocolate to vanilla is 2 to 1. So the chocolate has 2 times 567. I'm losing it. The chocolate is worth 2 times 567. And then in the vanilla is, of course, just worth 567. And I just don't have enough space. I'd like to be able to just keep this vertical, but I have to write it over. 2 times 567, now that's actually 1134. And the vanilla is worth 567. And notice if you add them, the total, it's 1701, which is off by a penny. That's a rounding thing, so that checks. Notice this answer is different than the one we got before by a penny. It's the way, it's a rounding error. So you can be off by a penny, it's not a problem. But one check for the value of each half is when you add the 2 halves up, it better be the total value of the cake. Okay. Now, what's the value of the vanilla half to Bob? Well, we already saw way 1. It's just going to be 17 divided by 3, which is 567. So the value of the vanilla half falls right out when you do the chocolate half this way. What if you did the chocolate half the first way? Well, you could get the value of the vanilla really a couple ways. I could do a third way, maybe I will, by simply taking 17 minus the value of the chocolate, and that would be 567. And then there's way 3, which would be doing it exactly the same way we did as the chocolate. The vanilla half is 1/3 of the total value. And so that's 1/3 of 17 of his times. And there it is, it's 567 again. Okay, so different ways to get the value of the vanilla half. Now, last problem for this page. What is the dollar value of this slice to Bob? So it's 140 degrees of chocolate. It's all chocolate, 140 degrees of chocolate. Now, again, 140 degrees, that's a weird slice. Let's change this to an easier problem. What's the value of 90 degrees of chocolate? So let's kind of visualize this. And here's the chocolate. 90 degrees of chocolate would look like that. What would that be? Well, isn't that half of all the chocolate? And then all the chocolate was, there it was, 1134. It'd be half of 1134. So it would be 567. Okay? So that's how I would do it if it was half the chocolate. Now think about it. The real key here to figuring out that 567 was to realizing that 90 degrees was half of all the chocolate. That's what allowed me to go 1/2 times 1134. So if I want to deal with this weird number, 140 degrees of chocolate, this is what I need to ask. What fraction of all the chocolate is this slice? Now, you do have to remember a little bit of geometry. There's 360 degrees in a circle, so there's 180 degrees in a half circle, and you do need to remember a fraction is always part to total. That's all a fraction is. So the part that we have is 140 degrees. The total chocolate, not the total cake, but the total chocolate is 180. So this slice is 140 over 1/80 of all the chocolate instead of half the chocolate. But we're going to do it the exact same way now. If you want, you can reduce this fraction or not, but this slice is as equals, I'll do 14 over 18, that's reducing that, of, which is times, now be careful here, it's not of all the cake, it's of all the chocolate. So all the chocolate, you could use the 1133 or the 1134, it won't matter to me. I think I use the 1134. And you punch that into your calculator and you get 882. Remember, round this to the nearest penny. Okay. That's how he would look at that piece of cake. Now again, you know people don't bring protractors and calculators out when they're cutting cake, but we're trying to get to seeing shares from each player's point of view. So Bob would put a value of 882 on that piece. My question to you is, if Susie had actually cut the cake like that, something like that, would he be satisfied with that slice? Well, you know, Bob would be satisfied. With this slice, since a fair share is 850. He pitched in 850 worth of cake, and this is over the fair share. You know, this slice is worth more. So he's getting more than his fair share. Okay. Now, Susie wouldn't think that was fair, because to her, cake is cake, and so she would actually never cut the cake this way. But this is, we're going to continue on with more problems like this in Notes 1. But again, for some people, this is the hardest problem that we cover, and then the other thing that can be hard is Jefferson's method, which is the last thing we do before test 3. But if you are having trouble with this, don't run away from it. Get help. Make sure you come to class. We'll definitely work on this type of problem on the worksheets.